Hello and welcome to another exam paper walkthrough. So in today's video I'm going to be looking at a GCSE Maths AQA paper. And this is going to be a predicted topic paper, but it's going to be the shadow version. So a few weeks ago I released a predicted topic paper. What I've done is I've gone and made a shadow version out of it. So essentially all I've done is kind of rework the questions a little bit, give them different numbers. So it's the same skill, but with fresh numbers. Attached to the description to this video you'll find a link where you can download a copy of the paper. You can either download the shadow copy, or you can, if you want a bit of extra support, you can download the copy of the problem pair. So what I've done is, for the problem pair, I've put the predicted topic paper solutions next to the shadow, so you can just get that extra little bit of support because you've got the worked solution on the left and then you attempt the one on the right. Again, so this is preparation for the June 25 series, and this is obviously paper 1, and we're looking at the higher tier. If you've not already done just the predicted topic paper, I would recommend you do that one before the shadow. And the shadow is kind of used as a final bit of prep for your exam. I would recommend having a bit of music on in the background. I've got some music on while I'm recording this on an earpod. I just find the exams more enjoyable if I've got a bit of music on in the background. If you find this video useful, please do subscribe. And as soon as my paper 2 material comes out, or paper 3 material, you'll get a notification as soon as they're dropped on my channel. Right, let's start the paper. Okay, so question 1, we're looking at factorise x squared minus 3x minus 27. So we're going to factorise it into 2 brackets. Both brackets are going to start with an x. And then we're looking for 2 numbers that multiply together to make the back number. So multiply together to make minus 28, and that add together to make minus 3. So that means that one of them is going to be positive and one of them is going to be negative, and it means that the negative is going to be 3 bigger than the positive number. So if I just put my positive and negative signs in for now. Right, multiples of 28. So we've got 4 and 7, which are the difference of 3. So it's going to be minus 7 and plus 4. So x plus 4 and then x minus 7. Question 2. Sophie is X years old. Jack is twice as old as Sophie. Mia is 3 years younger than Jack. The mean of their ages is 12. How old is Mia? Okay, so I'm going to say that their total age then is going to be 12 times by 3. So their total age is going to be 36. And then if I start to set it up, we've got 3 people. We've got Sophie, Jack and Mia. We're told Sophie is X. Jack is twice as old, so Jack would be 2x, and Mia is 3 years younger than Jack, so that would be 2x minus 3. And we know that their sum now needs to be 36. So if I add these 3 parts together, I'm going to get 5x minus 3, and that's going to be equal to 36. Okay, and straight away I can see that I've slightly messed up here, so I'm not going to get a whole number for my answer, which is okay. We'll work in terms of a decimal, or probably in terms of a fraction. So I'm going to start by adding 3 to both sides then. So that's going to give me 5x has to be equal to 39. I'm then going to divide both sides by 5 and say x is going to be equal to 39 over 5. So 5 goes into 39 fully 7 times, with 4 left over, so I'm going to say 7 4/5. Right, that's not quite what we were asked to work out, though. We were asked to work out Mia's age. So Mia is 2x minus 3, so 2x minus 3. So I'm going to return to this version. Actually, I'll be fine with working with a fraction. So if I double this fraction, I'm going to get 14 8/5, which is going to be the same as 15 3/5. So I'm going to say it's 15 3/5 minus 3. So that's going to be 12 3/5. So I'm going to go for my answer of 12 and 3/5. Apologies that that's not a whole number, but I'm sure that you're all more than capable of dealing with that. Right, question 3. Circle the value of sine 30. So if you can't remember sine 30, it's found by imagining a 2 by 2 by 2 equilateral triangle and then splitting it in half there. So if I take those two lines off and just imagine that I've got there, and then a 30-degree angle would be here, and then we've got 2 for my hypotenuse and 1 for my opposite, and sine is equal to opposite over hypotenuse, so sine of 30 would be 1 over 2. Question 4. Solve 4w over 9 is equal to 2 over 3. So I'm going to times through by 9. That would give me 4w on the left, and on the right, if we do 2/3 times by 9, that would become 2 times by 3, because 9 divided by 3 is 3. So that's going to be is equal to 6. Then if I divide both sides by 4, I get w is equal to 6 over 4, which would be 3 over 2, or 1.5. So w is 1.5. Right, question 5. Simplify. 4 times 10 to the 4 is 2. 2 times 10 to the minus 2. Giving your answer in the form n to 1. Okay, so if I've got it as this, what I'm essentially going to do is, to get 1 on the right, I'm going to divide both sides by 2 times 10 to the minus 3, to the minus 2, sorry. Or is it easier to convert straight away? I'm going to do that. So I'm going to say that this is going to be the same as 4 times 10 to the 4 divided by 2 times 10 to the minus 2. And that's going to be to 1. Right. So 4 divided by 2 is going to be 2 times by 10 to the... And if I do 10 to the power 4 divided by 10 to the minus 2, that's going to become 10 to the 6 to 1. So that would be fine as my answer, or I could convert it to being 2 million. I'm going to convert this one to being 2 million. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So question 6, solve. So the first thing I'm going to do is factorise. So like with the earlier question, both brackets are going to start with an x. I'm looking for two numbers that multiply together to make minus 2, but one of the numbers plus the other number need to add together to make minus 4. And my 12 is missed there. So I'm looking for two numbers that multiply together to make minus 12 and add together to make minus 4. That tells me one of them's got to be negative, so I've got a positive and a negative number. And that my negative needs to be 4 bigger than my positive, so I'm looking at minus 6 and 2. So minus 6 and 2. So for two things to multiply together to make 0, it means that one of them must be equal to 0. So either this is equal to 0, in which case x would be minus 2, or this is 0, in which case x would need to be 6. So those are my two answers. Either x is equal to minus 2 or x is equal to 6. Question 7. Will wants to buy a table that costs £150 and 4 chairs at £25 each. A 12% discount is applied. VAT at 20% is then added to the discounted price. Find the final cost. Right, so first of all I want the total cost then, so I'm going to do 150 plus 4 times by 25, so that's going to be 100. So we've got a total cost of £250. Right, so I want the 12% discount is applied, so I want 88% of this price. The way I'm going to do it though is I'm going to break it down and find 12% and then take that away. So if I say that, let me set that out slightly better. So the full price is going to be 250. So 10% is going to be equal to 25. So 2% is going to be equal to £5, because if we think about it, 2%, 1% would be 2.5, so 2% would be double that. So 12% is going to be equal to £30, and I need to take that away from the original price. So if I do 250 minus 30, that's going to give me £220. Right, now I'm going to add on 20%. So again, if I use a similar method to this and start by saying that, so I should leave a space, I've changed colour instead. So the full price that I want to add 20% to is 220. So 10% is going to be equal to 22. So 20% is going to be double that, so 44. And then, so finally I want to do 220 plus 44, which is going to give me 264. So the final price then is going to be £264. Question 8. Solve x plus 29 all over 2 is equal to 3 lots of x plus 14. Right, so I'm going to start by getting rid of this denominator by timesing both sides by 2. That would give me x plus 29 is equal to 6 lots of x plus 14. Now if I expand this bracket, that would give me x plus 29 is equal to 6x plus 14 times by 6. 10 lots of 6 is going to be 60, 4 lots of 6 is going to be 24, so we're looking at 84. Right, I'm going to move my x's to the left, to the right, and my numbers to the left. So, and I'll do the subtraction slightly separately. So if I say I want to do 29 minus 84, I'm going to say that that's, just to make it easier for myself, 84 minus 29, and then I'm going to take the negative value of that. So 4 take away 9 we can't do, so we exchange. So 5, and then 7 take away 2 is going to be 5. So we're looking at minus 55 for my number part. So minus 55 is going to be equal to 5x. Divide both sides by 5, that gives us minus 11 is equal to x. So x is going to be minus 11 here. Question 9. Write the number 14,003,700 in standard form. So 14,003,000, so and 700 in standard form. So the trick here is, obviously the most complicated bit is actually forming the number, and then if I want that in standard form, that's going to become, decimal point goes between the 1 and the 4, so 1.4 times by 10 to the power, and then the decimal place. So I've moved it 7 places, so that's going to be 1.4 times 10 to the 7. No, I've missed off my other digits. So 1.40037, so 1.40037 times 10 to the 7, and I've missed my times 10 to the 7 there as well. There we go. Question 10. Y is inversely proportional to x. So if it's inversely proportional, that means as y increases, x decreases. So I'll say y is equal to k over x. So if from here to here I've times by 2, that means from here to here I would divide by 2. So that's going to be 1.5. And then if to get from here to here I have times by 4. To get from here to here I'm going to be doing the opposite, so divide by 4, so that would be 1. Question 11. Density is equal to mass divided by volume. The mass of solid A is 8 times the mass of solid B. The volume of solid A is 2 times the volume of solid B. Complete the sentence. The density of solid A is blank times the density of solid B. Okay, so what I'm actually going to do is I'm going to look at this, and I'm just going to refer to these as, if I just think about density B for a second, because we're told the amount that solid A is bigger. If I call that the mass would be X, and let's just call it that. So the density of A then is 8 times the mass of solid B, so whatever this mass is here, I'm going to be doing 8 lots of it, over volume A is 2 times the volume of solid B, so that would be 2y. So this would simplify down to 4x over y. So it's just going to be 4 times the density of solid B. Part B. Average speed is equal to distance divided by time. If the distance is doubled and the time is halved, what happens to the average speed? So if we've got an average speed as it is, so distance is doubled and then the time is halved, so that would have the effect of times in by 4. Because if you think 2 over half is the same as 4, so times by 4. Question 12. The nth term of a sequence is, and we've got this, work out the sum of the first and the 8th term. So we want to do the first term plus the 8th term. So let's start with the first term then. So the first term is when n is equal to 1, so that would become 1 times by 1 minus 3 divided by the square root of 1 plus 8. And then to that I want to add the 8th term, so that would become 8 times by 5 divided by the square root of 8 plus 8. Okay, so 1 times by minus 2 is going to be 1 times by minus 2 would be minus 2, and then the square root of 9 is 3. And I want to add that to 8 times by 5 is going to be 40 divided by the square root of 16, which would be 4. So I'm doing minus 2/3 plus 10, which is going to give me 9 and 1/3. So 9 and 1/3. Question 13. So if you were really on the board and downloaded an early copy of this, this actually said 8.825, so I'd made a mistake in the question. I have rectified it. If you've done it with 4.825, it doesn't actually work with one of these fractions. Apologies if you got one of the early versions. I hadn't really fully done a QA over it because I was trying to get them out in quite a rush. Let's do this one though with 4.875. So first of all, I'm looking for, when I convert it from a mixed fraction into, from an improper into a mixed fraction, I'm looking for an answer of 4. So these two would both give you an answer of 4. This one wouldn't. This one would, but it would be 4 1/4, so 4.25, so it's not going to be that one either. So it's going to be one of these two. So this one is the equivalent to 4 and 7 over 8, and this one would be the equivalent to 4 and 5 over 8. So 5 over 8 is too big really. It's 5 over 8 is going to give you a number just over a half, and this is too big, so I'm going to assume it's this one, and then I'm just going to do the division to double check it. So I'm going to say 8 go into 7.000, so 8s don't go into 7. We've got 7 left over then. 8s go into 70 fully 6 times, not 6 times, 8 times. 8 times 8 is 64, so we've got 6 left over. 8s go into 60 fully 7 times. And then 7 times 8 is going to give us 56, so we're left over with 4. And then 8's going to 40 45 times, so yeah, that one works. So we're looking at that fraction. Question 14. Here is the speed time graph for a 50-second journey. Circle the acceleration in meters per second squared halfway through the journey. So halfway through the journey, so we're looking at the acceleration here, which would be 0. So part B, work out the total distance travelled. So the total distance is the area of this shape. So I want to work out the area of the trapezium. So the distance is going to be equal to a half of this time here divided by plus this time here. So if you kind of view it as A and B. So we're going from 10 to 40, so that's going to be 30. And then plus 50. And then we times that by the height, so times by 30. So that's going to be half of 80, so that's going to be 40 times by 30, which is going to give us a 40 times 20, 40 times 30, well 4 times 3 is 12, and we've missed off 2 zeros, so we need to put them back on, so we're looking at 1,200 meters. Right, question 15, factorise. So we've got 6x squared plus 7x minus 3. So it's going to go into 2 brackets again, and we've got, I chose deliberately quite a difficult one because 6x, we don't know whether that's going to be, let's say, I'll put it in for now, 6x or an x, or it could be 3x and a 2x. And we don't know which, because that's not a prime number. This number, minus 3, is a prime number, or 3 is a prime number. So we know that that's got to be a 3 and a 1. One of them is going to be negative, one of them is going to be a positive. So we need to put a negative in there somewhere, because we want it to equal minus 3. But we don't know at the moment whether it's 6 lots of one of the number plus the other number to equal 7, or 3 lots of one of the number plus 2 lots of the other number to make 7. So if you start trying to work out a combination of putting 3 and 1 in where one of them is a negative value, we can see if we do it this way around, 3 times 6 is 18, so that's not going to work. If we do it the other way around, 3 times 1 is 6. 6 and 3 can't go together, so we know that it's not going to be that one. Right, so 1 and 3 here then. So if I put 1 here, that would give me 3 and 6, so that wouldn't work. If I put the 3 here, that would give, here we go, that would give me 9, and then we'd want the minus 2. So 9 take away 2 would equal 7, so that's my combination. So I want the minus 1 to go in the bracket opposite the 2, so it's got to go minus 1 there, and we've got to have the 3 there. So that's going to be my factorised version. So 3x minus 1 and 2x plus 3. Right, part B. Simplify fully. So we've got 2 quadratics, we've got a difference of 2 squares on the bottom, which is where I'm going to start with this. So if I leave the top for now and say that I want that to be x plus 3 times by x minus 3, and that gives us a bit of a hint for our top line, because we would like to think that if we're simplifying, one of these terms on the bottom number is going to be in the top line as well. So we're after 2 numbers that multiply together to make minus 12 and add together to make 1. So because of that, we've got one of them is going to be negative, one of them is going to be positive, and the positive is going to be 1 bigger. So we're looking at 4 and minus 3. That works fully. So one of the brackets is a +4, the other one is a -3. And then we've got -3 on the numerator and the denominator, so they will cancel to just give us x + 4 over x + 3. Question 16, and again, if you did an original version of this paper, we've got slightly different numbers here, so I hadn't totaled 10 as it was, so I've changed these slightly just to make it correct. Apologies if you got the early version of that paper. Okay, so the table shows information about the time 20 people, times for 20 people to complete a task. These statements are about the mean and the range of the actual times. Tick the correct box for each statement. So the mean could be less than 20 minutes. Less than 20 minutes, no, that couldn't be true, because if we think about it, mean could be less than 20 minutes. So less than 20 minutes is, there's only 2 people. So even if like all of these were just over 20, we still couldn't have a mean, so that one's going to be false. The mean could be more than 40, so again, that one couldn't be true. So even if these were 20, that would give you 40. Even if all of these were 40, that would give us, it just wouldn't work. So that one's going to be false. The mean could be less than 40. That one would be true, because if we think about it, we would, if we were doing an estimated mean, we'd get it fitting in this, so that one could be true. The range could be more than 40. So the range could be more than 40. So if we imagine this was very low and this was very high, that one could be true. The range could be less than 40. So if that was 20 and those were 41 each, that one could be true as well. The range could be more than 60 minutes. That one couldn't be true, because even if it could be arguably 60, but so it couldn't be more than 60. Right, question 17, giving your answer, work out 3 over root 3 times by root 5 over root 6. Give your answer in the form x root 10 over y, where x and y are both integers. Okay, so if we imagine this, if we do this multiplication to start with, so that will give me 3 root 5 over root 3 times by root 6 would give us root 18. Right, I'm going to look at root 18 just briefly before I move on. So root 18 is going to be the same as root 9 times 2, so it would be 3 root 2. So let's just change that slightly. So we're going to call that 3 root 5 over 3 root 2. I'm only going to do this as a shortcut just because I find it easier. So rather than times through by the denominator, I'm just going to times through by root 2 over 2 to rationalise the denominator. I could have times through by 3 root 2. I would have just ended up needing to simplify that anyway though. So if I just times through by root 2, that would give me 3 root 10 over 3 times 2 over 6. And technically that would do for my answer, because it doesn't say in its simplest form. Give the answer in the form, so that's in the form. Although I could simplify further by saying 3 goes into both those numbers. So 3 would go once into there and twice into there. So technically 1 root 10 over 2, which is the same as root 10 over 2. And I could see an argument that that's not in the form, although x is just 1 here. So that's okay. Not overly well thought out by me, but that's all right. Question 18. Triangle cross-section prism is an isosceles right-angled triangle. The volume of the prism is 392 centimeters cubed. Use approximations to estimate the value of x. You must show your working. Right, so let's look at our estimations here. So I'm going to start by saying 392 is approximately equal to 400, and I'm going to say that 8.14 is approximately equal to 8. So if the total volume is that, then the total volume of the prism is going to be, well, the volume of the prism is going to be equal to the area of the triangle, so that would be a half of x times x, or x squared, times by 400, times by 8. And we're going to say that that's approximately equal to 400, so 400 is equal to a half of 8 would be 4, so 4x squared. Divide by 4, so 100 is equal to x squared. And then if we square root that, we can't have a negative length, so we're going to go 10 is equal to x. So approximately 10. Question 19. In a box there are some buttons. 135 are large and the rest are small. Some are yellow and the rest are green. The total number of small buttons is 5/3 the number of large buttons. The number of green buttons is 300% the number of yellow buttons. There are 36 small yellow buttons. How many large green buttons are there? You may use the two-way table to help you. Right, so let's put some of the information in. So 135 are large, so 135 will go there. We can use that, but we'll come back to it in a second. The number of small is 5/3 the number of large, so we've got more small than large. The number of greens is 300% the number of yellow. There are 36 small yellow buttons, so 36 can go there. Right, so we've entered that bit and that bit. Right, so I'm going to start with the number of small buttons, which is going to be 5/3 times by 135. Right, 135 divided by 3 is 45, so I'm looking at 5 times by 45, which is going to be equal to 225, I think. Let's just think. 5 times by 50 would be 250, and this will be 5 times 5, 25 less, so 225. Right. Next one that I'm going to do is we've got, if I call yellow x, then green would be 3x. And if we've got 135 plus 225, that's going to add up to 360. That's quite a nice number to work with. So if I do 360 divided by 4, that's going to give me 90. So that means we've got 90 there and 270 there. And I can kind of finish it off from here, I reckon. So let's just change pen colour for... So I can work out this value by saying that's going to be 225 take away 36. So that's going to give me 9, 8. So I'm looking at 89 there. Just double check that. 36 plus 36 plus 9 would be 45. 45, yeah, that would work. Right, now technically this is the value that I want and the only value that I want, so I'm going to actually do that two ways, so I'm going to hold off on that one for a moment. So this value here is going to be 90 minus 36, which would be 54. Right, so that leaves me with this final value should be both of these answers, so it should be 135 minus 54. And it should also be 270 minus 89. So let's work it out twice, and hopefully that will mean that we're right. So 5 take away 4 is going to be 1. 3 take away 5 we can't do, so 13 take away 5 is 81. So hopefully that works. So can't take 9 away from 0, so we exchange. So that would be 1. We can't do that, so that becomes and my minor mistake here is, you might have spotted it, I missed a 1 out there. So that doesn't change much though. So 16 take away 8 is 8, and then 1 take away 1 is, so either way that does work out to be 81. Right, question 20. So again, if you got the original version of this paper, there was a quarter in here, and that just didn't work out, so I hadn't fully thought the question through. Question that we should have, and apologies if you've got the early version, 2 times by sine 60 times tan 60 times cos 60 is equal to sine y. Work out one possible value for y. You must show you're working. So again, all of these are 60s or 30s, so the triangle I need for this is the equilateral split in half. I did explain that in a bit more detail before. So if I had an equilateral triangle and cut it in half with a perpendicular, that length would be 2, that length would be 1, that length would be root 3, and then we'd have a 60-degree angle here and a 30-degree angle here. Right, I need all 3 of my ratios for this, so S is equal to O over H, cos is equal to A over H, and T is equal to O over A. Right, so this is going to become 2 times by sine 60 is going to be root 3 over 2, times by tan 30, which is going to become 1 over root 3. If you're using the rationalised version, that's okay. Just I'm not going to here because it's actually shorter for me not to. And then cos 60 is adjacent over hypotenuse, so 1 over 2. Right, we can do quite a lot of simplifying here then. So those would cancel, and we'll say those would cancel. So we'd just be left with a half. So a half is equal to sine y. So if we think about sine being opposite over hypotenuse, and a half we've kind of got here. So that's going to be just, the sine of 30 is equal to a half. So our size of y would be 30 degrees. And that's one of the possible answers. If you've done anything else, you can kind of add 360 to it. That would give you the same value. Or you could do 180 minus, I think. That would work as well. But that's going to be the answer that we're really after. Right, question 21. Y is equal to 3x minus 7 over 2x. Make x the subject. So we've got x appearing twice. So our first thing is we're going to multiply through by 2x. So we're going to say that 2xy is going to be equal to 3x minus 7. Right, I am actually going to move my x's over to the right and my other parts over to the left, so that would give me 7 is equal to 3x minus 2xy. I'm then going to factorise the right hand side by taking an x out, 3 minus 2y. I'm then going to divide both sides by the bracket, so 7 over 3 minus 2y is going to be equal to x. So x is going to be equal to 7 over 3 minus 2y. Question 22. Here are the first 4 terms of a quadratic sequence. Work out the expression for the nth term. Right, so we're going to start by looking at the differences, and quadratic means that we should have a pattern in the second differences. So first set of differences we'll do in green. So difference between those two numbers is 3, those two numbers is 7, and those two numbers is 11. So second differences, we'll go orange. So difference between those two is 4. Difference between those two is 4. So the second differences of being 4 means that there must be a 2n squared within our sequence. So if we start by looking at the values of 2n squared, so 1 squared, 1 times by 2 is 2, 8, 18 and 16, 32. Now we want to look at the differences. So all of my sequences are... No, that's not true. So if I look at the differences, then, and I'm going to do it this way around, so the difference from there to there is plus 1. Difference from there to there is minus 2. Difference from there to there is minus 5. Difference from there to there is minus 8. Right, so difference between these numbers are minus 3, minus 3, minus 3. So if I wanted to describe this sequence, it would be minus 3n. So minus 3n. And then what do I need to do to minus 3 to get to the number 1? I would need to plus 4. So my sequence is going to be, so this is my difference. So I want to do 2n squared plus the difference. So 2n squared plus the difference. So that's going to become 2n squared minus 3n plus 4. Question 23. A times by 10 to the n is a number in standard form. Complete the inequality for the value of a. So the number has to be greater than or equal to 1 but less than 10. Question 24. C times 10 to the minus n is the number 0.0054 written in standard form. Work out C times 10 to the n. Write your answer as an ordinary number. Okay, so if I start by converting this into standard form, is going to be equal to 5.4 times 10 to the minus 3. So we want the value of 5.4 times 10 to the 3, which would give us 5,400. Okay, question 25. Here's a list of 11 whole numbers in numerical order. The lower quartile, median, upper quartile and largest value are missing. The median is 2 times the lower quartile. The upper quartile is 2.5 times the lower quartile. And the range is 2 times the interquartile range. Complete the list. Right, so I'm going to start by, I'm going to kind of say that my lower quartile is mentioned quite a few times. And actually we can kind of refer to it because if I called the lower quartile x, the median would be 2 lots of the lower quartile, so 2x, and the upper quartile would be 2.5 times x, and then we'll leave the largest value for now, although we can kind of say that it would be 1.5x. No, that would be, ignore that for now. The interquartile range would be 1.5x, so it would be, actually we could say 3x. Because if it is 2 times the interquartile range would be this value, take away this value, so 2.5x take away x would be 1.5x, so if it's twice that, that's in, actually that wouldn't be, that would be the, arguably 3x minus 7, so I'll leave that for now. Right, so let's start by thinking about the possible values for x. So possible value for x is in theory, we could have it as 10. It's got to be a number between 10. It could be 10, 11, 12, 13, 14 or 15. 2x, right, let's hope that, so it couldn't be 10 because 2 lots of x needs to be bigger than 21. So it could be 11 for now. If we start looking at the larger values, so it couldn't be 15 because 2 lots of x would be 30, so that would be outside the range, and it couldn't be that one either. So we can kind of say that it's got to be one of these three. However, if we think about 2.5x, you can't really, if they've got to be whole numbers, 12 really would be the only one that would work. So let's just see whether that would work. So the median could, so x, if we say x is 12, then 2x would be equal to 24, so that would still work. 2.5x would be 24 plus another 6, so that would be 30, which technically would still fit. So that would work so far, so that's 2.5x. And then let's think about the range is 2 times the interquartile range. So the interquartile range here would be equal to 30 take away 12, which would give us 18. So 18 times by 2 would give us 36. So yeah, I mean, there's no reason why they would not work. We've got a couple of repeated values, but that's not a massive issue. So I'm going for, let's change pen color to put these in. So I'm going for 12, and I'm going to miss one out for a second. 12, 24, 30, and then this is 2 times the interquartile range, so we want the range to be equal to that, so we've got to add 7 to that to actually get the largest value. So 36 plus 7 is going to give us 40. So that final value would be 43. And yeah, that works okay. Right, question 26. So we've got, prove that y is equal to 90 minus 1.5x. Okay, so I'm going to say that that's going to be equal to 3x first of all. So I'm going to say that RQP is equal to 3x. And my reason for that is it is the alternate segment theorem. And then I'm going to say that that angle there must be equal to y. So I'm going to say that RPQ is going to be equal to y, and the reason for that is base angles of an isosceles triangle. And then if we put them all together, then so they need to add up to 180, so 2 lots of y plus 3x must be equal to 180 degrees. The reason for that is angle sum of a triangle. Equals 180 degrees. So if we rearrange this for y then, so y is going to be equal to 2 lots of y, let's say, 180 minus 3x. And then if we divide through by 2, that would be 90 minus 3 over 2x. And we wanted it to be minus 1.5, which it is. So y is equal to 90 minus 1.5x, which is what we're asked to show. Question 27. A coin is thrown 80 times. It lands on heads 32 times. Write down the relative frequency it lands on heads. So that would be 32 out of 80, which we can simplify through by quite a bit. If we start by doing eighths, so 8 goes fully into 32 4 times. So 4 over 10, which is 2 over 5. So Raj says the coin is biased towards heads. Use the data to give a reason why this might be correct. So the expected frequency would be we would expect a value closer to 40 out of 80. So it is we could even say it's 10% out, because there would be 8 times out. So we would expect a value closer to 40 out of 80, so it is quite low. Quite a bit lower. Question 28. 4 whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 90. Work out the maximum possible value of the original numbers. Okay, well, let's just imagine to start with, let's say something has been rounded to 10 instead of 20. Now, technically, the middle point would have been 15. However, 15 we would round up. So the maximum it could actually be would be 14. So I've looked at 10, but each of these numbers has been rounded to the nearest 10. So all of the numbers could have actually been 4 bigger. So 4 times by 4 is going to be 16. So we could be 16 bigger. So 90 plus 16 is going to be 106. So 106. Okay, question 29. A journey has 2 stages. Stage 1, stage 2, we've got distances of 45 for both, average speed over A and B, and then the time would be 45 over A or 45 over B. Show that the average speed for the whole journey in kilometres per hour is 2AB over A plus B. Okay, so total distance for the journey is going to be 45 plus 45, so if I kind of add a total column here, so that would be 90. And then the total time would be 45 over A plus 45 over B. So I'll put them over a common denominator of A times B. AB. And then this one would be times by B, so that would be 45B. And this one would be 45A. Right, so I've got a total time of, we'll put 45 lots of, and then we'll put A plus B divided by AB. Right, so if I want to find the total speed, the average speed for the journey, speed is equal to total distance divided by total time. So that's going to be 90 divided by, we'll put it in as a division for now, 45 lots of A plus B over AB. And then when we divide by a fraction, it is the equivalent to multiplying by the reciprocal. So, and then we'll simplify that. So 45 goes into 90 twice. So that's going to become 2AB over A plus B, which is what we were asked to show. Okay. Question 30. 12 machines work at the same rate. Together, the 12 machines can complete an order in 12 hours. 4 of the machines break down after 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work for? So, if 12 machines will take 10 hours to finish a job, then we've got 12 times by 10. We've kind of got 120 working hours. So that would take, it would mean kind of one machine would take 120 hours. 2 machines would take 60 hours, and so on. So 4 of the machines break down after 6 hours of work. So let's see, 12 times by 6 would be equal to 60, 72. So the 6 machines in those 4 hours would have completed 72 of the 120 worked hours. So that leaves us with left to be worked 48 hours, I believe. So we've got 48 hours left to be covered. We now haven't got 12 machines. We've now only got 8 machines. So those machines, 48 divided by 8 is going to be 6 hours. More. So we've got the original 6 hours plus the additional 6 hours that they've got to work. So that makes a total of 12 hours in. But the 8 machines are going to have to work, so 12 hours in total. Okay, and question 31. A, B, and C are points on a circle. X squared plus y squared equals 49, as shown. Okay, A is on the y-axis. B is on the x-axis. M is the midpoint of AB. And COM is a straight line. Show that the coordinates of A are 0, 7. Okay, so the point A, if it's on the y-axis, it must be 0, A for now. And then if we're saying that x squared plus y squared is equal to 49, then we can say that 0 squared plus A squared is equal to 49. So A will be equal to the square root of 49, which will be technically plus or minus 7. But we want the positive, so y is positive. So y is equal to positive. So it must be at the point 0, 7. Okay, calculate the point of B, or the coordinate of B. So B is going to be almost identical, except for the point B. If B is on the x-axis, we know that it's going to be at the point B, comma 0. And then just like here, we can say that B will also be equal to 7. So we're looking at 7, 0. Show that the equation of the straight line passing through COM is y is equal to x. Okay, so we know first of all that the origin is at the point, so the origin is equal to 0, 0. and we know that, well, we don't know. Next thing I want is m. So if m is the midpoint of AB, it's going to be equal to 7 plus 0 over 2, comma, 0 plus 7 over 2, which is going to be 3.5, 3.5. And then, so if I look at saying that that's y is equal to mx plus c, then we know that technically we can say that the gradient is going to be equal to 3.5 over 3.5, which would be 1. So y is equal to x plus c, and if we use the coordinate 0, 0, we can say that that means that c is equal to 0, so y must be equal to x. And then finally work out the coordinate of c given your answer in surd form. Okay, so we know that it's going to be on that line. We know that it's going to be on the line of that. So we know that for the coordinate c, we know that it must be at the coordinate x comma y. And we know that these two values must be the same, so let's call it c comma c. So we know that if we're saying that it's on the coordinate x squared plus y squared equals 49, so we can say that 2 lots of c squared must be equal to 49. So c must be equal to plus or minus the square root of 49 over 2. So it must be equal to plus or minus 7 over root 2. And then if I rationalise that, that's going to be 7 root 2 over 2. So it's going to be minus 7 root 2 over 2 minus 7 root 2 over 2. And that brings us to the end of this paper. So I'll bring up the question level analysis, which will give rough grade boundaries. Okay, so I will try to chapter index this video by the topics, just if you want to direct some further independent study at those aspects. Rough grade boundaries for the paper are kind of here, alongside question facilitated by grade. That tells you how when this paper was sat, the original version, not the shadow version but the original version, each question was actually an original one from an exam series, and that gives you how well it was accessed by a student at specific grades. Thank you very much for your time in watching the video. I hope you found this useful. Please do subscribe if you like, and you'll get any notifications as soon as any paper 2 or paper 3 material are released. Good luck with the rest of your revision. I hope you do really well in your exam, and I will see you soon.